Okay. Oh my God, I'm loving the conversations on the chat. I see a lot of Nigerians there. You guys are so into this song. And thank you again for voting for the song, because if it weren't for you, we wouldn't be here with this jam right now. So thank you again. I see Ghana there, Malawi, South Africa, Nigeria, the Rwandians are in the house. Cameroon, welcome guys, and thank you for joining us today. My name is Tendai. I will be your host today, and I'll be co-hosting with Munesu, who is our data scientist in the house, and she is going to be taking us for today's session. But before we get busy and all that, we just need to remind each other of how we do things around here. So first we'll have our rules of engagement, and then our main session with Munesu, and then the question and A section. Then we'll just take each other through our support channels, and then we'll update you on anything that needs to be shared with you in announcements. So our rules of engagement, please, if you have any question, no matter how small, if it's during the session, just drop it on the Q&A. Our tutors are here and they are going to answer you. And feel free to use the chat liberally and respectfully. We will be opening it ad hoc throughout the session just to keep things orderly. But yeah, Munesu is going to get you guys busy. So there's going to be a lot of activity in the chat today. But most importantly, please listen, learn, and engage. So for today's session on entity relationship diagrams and joins, Munesu is going to be taking you guys. So if you've ever wondered how tables in a database connect and communicate with each other, then today is the session for you. So I'll hand it over to Munesu to take you guys on a session. Over to you, Munesu.
All right, thank you so much, Tendai, and thank you for the introduction. And hi, everyone. I hope everyone is doing well, and hopefully, things are going well. If they aren't, it's okay. So I think the first tidbit or advice that I'll give anyone who is struggling or who feels like this is all too overwhelming so far in the journey, I'll give you the same advice that when I was struggling through my data science journey, pushed me through. So I attended a webinar and I remembered this, someone saying, do not worry if you do not understand anything. It's not that you're dumb, it's just that you're inexperienced right now. So guys, all you need to do is keep on practicing, keep on putting the work, and one day you'll come out on the other side of what seems to be a storm of learning. All right. So before I do go into the session, I'd love to say I was reading on eHub in the community how they call me the English Rose. I've been trying to run away from people saying I've got an accent because I don't believe I have an accent, but a lot of people say I do have an accent. So yeah, there's that. But that's all right. And my internet has been unstable. So what I'm going to do is I'm going to switch off my camera so that we can have the smoothest webinar without me having to log in, log out, log in, log out, and so that you'll be able to hear me. So please do bear with me, and if that's all right and we understand each other, please do give a thumbs up as I disappear. All right. So today we are talking about ERDs and we're also talking about joins. And for that, or for us to understand everything better, we are going to go into the world of Majidongo. And in this world of Majidongo, we are going to focus on a specific person. And this person is called Moanwa Kayode. And this is Kayode's daughter. So Moanwa is a young, ambitious entrepreneur who just launched a big retail business. She's got a large shop that is filled with all kinds of products and a growing list of customers. Now, Moanwa is in Majidongo, where you guys are busy solving all the problems that are happening there. So, with Moanwa, since she's got this large shop, she's got all these products, and her customer base is growing a lot, she's trying to find ways to actually make the data work for her. So Moana loves Google Sheets to keep track of everything. Sorry, just a moment. Yeah. So Moana loves using Google Sheets to keep track of everything. This means her customers, the orders they're making, and the products they're buying. And all of this is in one big sheet. It seemed like a good idea at first. When you've got fewer customers, fewer orders, fewer products going, it's a good idea. And we just came from Google Sheets. So you can understand why she would think like, okay, Google Sheets is actually the best way to deliver or to track everything. But now, because her business is growing and she's getting more customers, things are getting complicated. All right. And so before, when it was just a small business and she was using the Google Sheets, it was fine. But now, because the orders are a lot, there are a lot of people that are ordering, we can see that there's a John Mwangi, for example, that is giving a lot of problems and she is being overwhelmed by everything that is going on. And so we can see why, okay, maybe Google Sheets is really not the best idea. And now, to even see or to perpetuate this idea, we can see that the customer names are being repeated. So, for example, we've got Fatima Abdallah, who's there, and we've got Fatima Abdallah again, who's being repeated. We've got another Chinwe Okeke and another Chinwe Okeke again. And so the customer names are repeating. Some customers order the same product, and it makes it impossible to tell who ordered what. So, someone can order a tablet, and maybe they might not be at the same address. And so now she's finding it hard to even track which customer had which issue with which product. So in essence, her customer service is falling apart. And so now what we're going to do is we're going to introduce Moana to this SQL and how to use SQL to create a database that can help her, keep everything in order and keep, track of what is really going on without her service falling apart, right? And so with that, we now start with what are entities, attributes, and records. So entities are an object, which is a person, place, event, or thing that is tracked in a database. So it's a type of thing that you're storing information about. So for example, in Moana's case, we need to store information about the customers. So a customer table in Google Sheets would then become our entity. Attributes, on the other hand, are the properties or traits of our entities. So in our example, we've got the customer table that has all the information about the customer. Now, the attribute or trait of a customer would be, for example, their name, their phone number, their address, their email, and any other information that might be in that table. So it's a detail or property that describes our entity. So that's what an entity is, and that's what an attribute. So as we can see here, when it comes to the whole larger database, just think of, entities as the tables that are working together to bring out different insights. And so here we've got the entity that is highlighted in purple, and then your attributes will be the ones that are highlighted with the green border here. And so let us actually look at an example of this. So our entity in this case, as I mentioned earlier, would be customers information. And so in the customer information, we can have things like the customer ID, their first name, their last name, their email, their phone number, their address, and where they live. And now this section that is in green is what we call attributes. And we can look at the second entity here, which is your products table. And in the products, you'd have things like your product ID, your product name, your category, brand, and price. Remember, so you can see that this product's attributes, they're describing, or they're traits that are describing what the products are. And then the final table is our orders table, which has order ID, order date, customer ID, and order status. And now in our database, what happens is all these different entities, they interact with each other and they've got a relationship that is going. And so let us move to the next one. So we've described entities and we've described attributes. So now let's describe what records are. So a record is a collection of attributes. Remember, attributes, they're describing, or it's a trait of an entity, but our record is a collection of all those attributes that describe a real world entity. So it's like one specific example of an entity. So a database can have many attributes. So remember how the attribute can be a phone number, an address, or other things like that. But each record will have data on just one item. So for example, our record will have information on just one specific customer within our entire entity and attributes, right? That's why we call it a collection of attributes. And so a record, for example, would be just this row over here. Let me go back and let me get a laser pointer on. So our record would be the information of just this one row. All right. And now I want you guys to remember this, that entities will always be depicted as rows, which is our entities here, and our attributes will always be depicted as columns. All right, that is very important to remember, especially into where we are headed. All right, so now we talked about entities, we've described attributes, we've described records. Now, there's a relationship that actually happens between all the different entities. So an entity relationship is a data model that represents database structure by capturing entities, tables, attributes, columns, and relationships. And it provides a visual representation of that data organization. So our relationship describes how the different entities are interacting with each other. So let us look at the tables or the entities that we actually have on the screen right now. We've got customers, orders, order items, and products. And you can see that there are these lines that are actually connecting each of these entities. And these are the relationships that we're talking about. And how are these relationships formed? You can see highlighted here, we've got an attribute called customer ID in customers. We've got that same attribute, customer ID, in our orders table. And the same goes for order ID in the order entity. We also have another order ID in the order items entity. All right. So these are relationships that keep the tables working together in the bigger database. And it helps Moanwa keep track of, oh, this is what's happening. We've got the customer's information. These are the orders that they're carrying out. And these are the order items that they have. And from the order items, these are the products they're getting from there. And so it's just the relationships helps us keep track of what is going on in each database or in each entity. All right. So in the charts, quickly, can you tell me which other entities do you think can be added to this? Yeah. Please open the charts. Sorry, the chat is just going to pop up on my screen so that I can see everyone's response. All right, invoices, nice. Yes, invoice. Sales agents, yes. Purchase, yes. Invoice, all right. So feedback, shippers, yes. Suppliers, vouchers. These are great responses. I love it. And I can see that we are all getting it. All right. And rewards, perfect. All right. So I'm going to stop the chats now and we'll continue. So as you all have said, rightfully, they can be delivering, shipping, purchases, vouchers, There's so many other entities that we can build upon. This is great. So we're all on the same page. So now that we know that there's relationships and everything, every entity is related to, each other, we need to establish the cardinality of those relationships. So we know that there is a relationship, but we don't know how the relationship is working. And this is where cardinality comes into play. So cardinality is essentially, trying to find how the information is flowing and how much of an item is in one entity and how the other is in another entity. So, for example, the customer ID, right? You can only have one customer represented in the customer's information, right? But the orders, one customer can make various and many orders within the order table. And so here in the customers would say the one customer then has multiple orders in the orders table. And the same goes from orders to order items. One order can have several order items within it. Same goes for the order items. One product will be in one order item. So it's just a matter of finding out the rule of thumb, which is min max. But don't worry, I will show you how to use the min max to find out how to establish your relationship and cardinality between the different tables. But for us to be able to do that, we actually need to understand a primary key. Right. So now Moana is telling us that each table needs a way to make sure that no two records are exactly the same. So this is where a primary key comes in. It's like giving each product in the store a unique barcode, right? Because everything, the laptop needs to have its own barcode, speakers, the car, whatever it is, everything needs to have its own unique barcode. That way, we'll be able to actually track like, oh, this is the product that was bought, or oh, this is the customer we are talking about. And so let's go into primary keys and foreign keys into a deeper explanation. So in a database, keys are used to identify records within a table and establish relationships between the tables. They are fundamental to maintaining our data integrity, enforcing constraints, and ensuring efficient data retrieval. And so now let's go into what is a primary key. So the primary key is a unique identifier that is used for each record or each row in a table. It ensures that there are no duplicate rows in the table and that each row can be uniquely identified using this key. And how we define it is when creating a table, it must contain unique non-null values. So for example, this is like your ID number, your student number, your customer ID, things like that. So key things to remember, it must be unique, it must not have any duplicates, and there must be no null values. Now, let's go into the foreign key. So a foreign key is a column or set of columns that correspond to a primary key from a different table. It acts as a reference to the primary key and creates relationships between tables. And it also establishes a link between our data in two tables, which ensures referential integrity. So remember how our tables were interacting with each other. That's what we mean by primary and foreign key. So now, when you go out into the real world and you get raw data and you do not know, okay, how do I set the primary key? How do I set the foreign key? How do I know which key, which column to actually give the primary key, foreign key? Let me take you through an exercise that will help you understand. So everything that I'll be teaching you today is based more on the logic of how to achieve what you need to achieve, right? So it's not just about, okay, this is the content, but I want you to actually think of these things in more logical steps that will help you, even when you've got raw data that doesn't make sense, you know how to attribute everything in place. All right. So how to identify your primary key? So remember that each entity in our ERD represents a table in a larger database. And we view our customer entity as a table with rows and columns. So remember our 3 rules of primary keys is that they must be unique, never changing, and never null. So we've got our customer entity over here, and we've got first name, last name, email, and all these other things. So let's now identify which one can be primary key. So in our case, we've got the first name here. Now, if we look at the records that are here, we can see that there's Mary, Mary, Mary. So Mary is repeated. So which means that we can't use the first name as the primary key. Why? Because the primary key must always be unique. Now, if we look at the last name, we also have repeat. We've got Johns and Johns. So once again, we can't use that one. Why? Because it has to be unique. Now, for the email, which of these rules in the charts, once again, which of these rules are being violated by email between the unique, never changing, and never null? And yeah, in the charts, please tell me which rule are we violating and why we can't make it the primary key for the email. Out of the 3 reasons why it can be the primary key, which one is the reason why this particular column or attribute can be a primary key? All right, are the chats open? Never changing, never changing, never changing, and now. Perfect, perfect. I can see you guys, you get it. Perfect, exactly. Emails can change and sometimes they can also be null. So it means that our email can't be a primary key. Phone number, same thing, never changing, and sometimes it can be null. So we can't use that one. Now for the address, we can see here, there's 2 addresses that are not unique. So it's repeating, therefore the address cannot be our primary key. The same goes for the city. There's repeated values here. So once again, it cannot be a primary key. Same for the state and same for the postal code. And so that leaves us with just one column or attribute, which is our customer ID. And that's how you pick your primary key. So out of everything that I've said about primary keys, the 3 things I want you guys to remember is that a primary key should be unique, never changing, and never null. All right, so I'll close the charts and then we'll go on to the next part. So since we've established what a primary key is, we'll now also establish what a foreign key is, right? So foreign key is a reference of primary keys. The PK here just means primary key, right? And a foreign key can be repeated in different entities. So let us do another mini exercise once again. I'll open up the chat once again and then ask this question. All right. So in our customer, we already established that the primary key is our customer ID. Now in the products table, which one, using the logic that we just went through, which one would be our primary key in this table? In the chats. Product ID. Perfect. All right. You guys are absolutely brilliant. We get it. All right. The primary key is our product ID. And now for the order table, which one is our primary key? Order ID, order ID, order. Perfect. That is brilliant, guys. Thank you so much. All right. So that is correct. The order ID is the primary key. And now remember we said foreign keys reference primary keys. So looking at this order table once again, which one would then be our foreign key? So the foreign key is an attribute that shows up in another table, right? Customer I, oh wow, great. This is absolutely amazing. I love this. I love this, guys. All right, you're all correct. All right, and now I'll close down the chats once again. So the foreign key that is in another table is just, your attribute from the original table that's there. So think of it as like a foreigner in another country, but still their home country is there, or as a visitor, in another table that's visiting there. And that makes it easier for us to then relate the tables or have that relationships between the different tables. All right. Another thing to note is, unlike your primary key, where it has to be unique, your foreign key can have many foreign keys in one entity. So for example, if this orders table also, it could possibly have product ID as well. So which means foreign keys, they can be multiple foreign keys in one entity. All right. Now, with that said, do not worry. This slide will be shared with you and with everyone with the recording, and you'll be able to download the information that you need here. So yeah, it's got the script that we'll be using, and it also has the notebook and MySQL Workbench questions as well. So everything that you need is included on these links. Now, with that said, we will move on to our SQL Workbench. So we've just talked about the theoretical part, and you might be like, okay, maybe I've got a bit of understanding now, but I need greater, understanding of what's really going on. So this is where we come into MySQL Workbench. So before I do go into MySQL Workbench, I'd like to explain that, I'll be using MySQL Workbench and the Jupyter Notebook because the Jupyter Notebook, why we're using it is because you've got an exam at the end of, MySQL sprint that you need to do in the Jupyter Notebook. So we need you guys to be familiar with how to operate in the Jupyter Notebook. However, MySQL Workbench, why we're including it is because I see a shock face. Interesting. Okay. So why we include the MySQL Workbench is because it's the standard in the industry. In the industry, usually you actually use your your SQL database tools like MySQL Workbench, Postgre, and all these other ones. So it's important that you know how to operate in both or in these types of tools. So yeah, so this is like your industry standard, and then the other one you're also learning. So these are all just tools that you can put in your belt, and you can be like, you know what? I know how to use both Jupyter Notebook and MySQL Workbench. So now that we've established that, let's talk about the ERD. So how you can set up your ERD in MySQL Workbench. Okay, so because I'm not able to see anything, can you give a thumbs up if you can see MySQL Workbench currently? Thumbs up. Okay, perfect. Thank you. So that at least we're on the same page. All right. So anyone who has any questions, please, instead of raising your hands, please direct them to the Q&A section. There are other technical mentors that are there, answering the questions. And if they can't answer them, then I will take the questions at the end of the webinar. All right. So now that we are here, we are now going to go into our ERD. So ERD in MySQL Workbench, how you can actually create it is, all right, sorry, before we actually do that, we need to import the data and make sure there's data for us to be able to establish the ERD or the diagram to show these relationships and the cardinality. So How we do that is we can come here. I'll just close these and say create database, sorry, create database. And we're going to call this database Mo1, I'll just say Moanwa. Remember to always close with this, with the symbol, and then I'm going to run that. So how I run that, since I'm using a Mac, I use Command Enter, or you can simply use these two lightning bolts. In Windows, if I'm not mistaken, it should be Control Enter if you want to run a single line. All right, so once we've run that, we can see, okay, our database has been created. Now, if we come here, you can see it's not yet appearing on this schemas pane. So how we can get it? Sorry, guys, let me just enlarge that so that everyone can see much better. If it's not appearing, what you simply do is you refresh this little refresh button, and you can see now that the database, it now appears. And there we go, our Moanwa, right? And now, if you want to use that database, that means you want it to be highlighted. All you have to do is say use, and then you call the database you want to use, which is Moanwa. And then we do that. And then when we run that again, you can see that database has now been highlighted. But in my case, since I had already set up Moanwa, and since it's the one that has been set up in our Jupyter Notebook, I'll make sure to just use the correct Moanwa. All right. So this was just me showing you how to create your database and how to make sure you're using the correct database in your SQL Workbench. All right. Now that we've done that, and we now want to see what the ERDs are within our Workbench. We go to database and we go to reverse engineer. This, guys, is available in a walkthrough on Athena. So if you haven't come across it, I'm telling you, go to Athena, you'll find a walkthrough there. All right. And so here you'll see this page that'll pop up, and we're just going to say continue. It's going to show you all these conditions that it's connecting, it's retrieving, and to check the server. We press continue again. In this case, I'm going to select Moanwa, and I'm going to press continue. And then I'll press continue once again. I'll say execute everything, and then, all right. Oh, it seems like our Moanwa is empty. I forgot one step, guys. Sorry about that. This can happen to the best of us. So because we created Moanwa, what we want to do is import the data in, right? So after creating it, you can come to this. For those using Mac, you can always do the, come to file, and then you open a SQL script. But in my SQL Workbench, you can also come to this little icon, the second SQL with the little file, press on it. And then we're going to look for Moanwa database. And I'm going to click on that. And now you've got the information, right? And what we're going to simply do is we want to run all this information. And you'll see that it's carried out within here. We've got all the information there, and that's okay. We increase that once again. So this is just information of all the tables. We refresh our schema because as you can see, the tables, there's nothing. Now, if we refresh the schema once again, you can see now there's tables. Now the information has been added in. So that's how you import your data into MySQL Workbench. And so now we can go back to the ERD. Let's close that one and say, let's add a new diagram. All right, this will take time. So let's go back to reverse engineer once again. We continue, choose Moanwa, continue. And now you can see here that our tables are here, or our entities, they're all here. And let's just do that. And when we execute and we press continue and close, our 6 tables appear over here. So we've got the customers table, we've got the orders table, order items, departments, and products. So I'm just trying to make them appear all once on the screen. There we go. So we've got your customer entities, orders entities, order item entities. Let's put products, product entity, category entity, and your department entity. Now, sometimes MySQL Workbench will be able to establish the relationship, and you see, the connection's already done. But if the connection is not done, I'm going to walk you through how to establish that connection or that relationship. So we do the one-to-many. You can choose this sign and you start by selecting the foreign key and then the primary key. So we can start with our big entity, which is customers, and the following entity, which is orders. And then we select the foreign key here, which is customer ID in here, and the primary key in customers, which is customer ID. And as you can see, when you hover on it, a relationship has been set. Now, how I came to this one-to-many, let me do it in another instance, right? So remember how I said when you're establishing the cardinality, you need to think of what's the minimum and what's the maximum. So let's walk through this exercise together. And please open the charts for this so that we can go through it together. When a customer, okay, so this is going from the order of orders to customers. What's the minimum number of orders that a customer can make? All right. Unlimited. All right. What's the minimum? What's the minimum, guys? What's the minimum that amount of orders a customer can make? 110. Okay. I see some are on the right track. Minimum. Yeah. So a customer can make 0 orders. I have a customer in here, but they don't have to make any order in here, right? And so that's the minimum. Now the maximum, what's the maximum amount of orders a customer can make? Unlimited, many. Yes, infinite, right? And exactly infinity, infinite. Perfect. So that's how we established, okay, since the minimum is 0 and the maximum we can say, what's the minimum orders, a customer can make? Again, it's 0. But, okay, can you hear me, guys? Can everyone hear me? Okay, perfect.
Yes, we lost you at some moment, but yeah, you're back.
Oh, okay. Sorry. So let me just quickly reconnect so that you don't lose me again. Sorry, just a moment. I'm quickly setting this up. All right. So as we're setting that up, as you said, minimum that orders a customer can make is 0, right? But now when we reverse it, minimum, how many, there can't be many orders for many customers, right? There can only be 1 customer, which is why there's only 1 here in the customers and many orders. So, we can't say, oh, we've got, 1 order for many customers. That does not make sense, right? And that is the reason why we then said, okay, so for customers, there can only be 1 customer, but they can have many orders. And so now using that same logic, which relationship do you think we can establish between order and order items? Is it a one-to-one, one-to-many, many-to-one, many-to-many, one-to-many? Perfect. All right. You guys are understanding? Yes. One-to-many. I see some many, but most are one-to-many. Great. That is correct. All right. And so we once again choose our one-to-many, choose the foreign key in our order items, which is the order ID, and then choose our, there we go. And so remember just using that min max, one order can have many order items, but one order item cannot have many orders. It's the same as this thing, right? Like one customer can have many orders, but one order cannot have many customers because it's set, right? Each order has the one specific customer alone. All right. Now I'll close the charts and quickly establish the other relationships as well. So we've got our product category ID, foreign key, primary key. Okay. Foreign key, primary key, and here you go. And you do the same once again for categories to department, foreign key, primary key. So yeah, when you're establishing your relationships, remember, rule of thumb, always have your primary key and foreign key, because those are the ones that connect everything together. And now the tables work together as a whole in our database. All right. Now that that has been explained, I'm sorry, I'm just going to do a quick switch off of my network so you don't lose me again. Now. Thumbs up if you can hear me once again. Okay, perfect. Perfect. Now that we've established our ERD and what is happening and how the relationships are going and how the tables interact with each other, let us now go into our Jupyter Notebook. So let us go back into our Google. Right. So we've established ERDs, we've established primary keys, foreign keys, we've established how everything works together and interacts together as one big whole thing, right? Now, I'll be providing this notebook once again with, it's in the slides as a link that you can just download. It will be in a zip file. Everything will be in a zip file, guys. So once you get the link, download the zip file and then open, and you'll be able to access all these things. Now, we're in our Jupyter Notebook, and we're going to be going through our joins in this case, right? So all the ERD did was help us set up our understanding for what is going to be happening with joins. So in our table overview, because we always need to understand what tables we have, what the information in those tables are, we're going to go, we've got 6 tables within our database, which is your customer, which is customer details, the orders, which is each customer can have many orders, our order items, each order can have many items within it, the products and their name and price, the categories, whether it's like accessories, water sports, or whatever it is, and then the department like outdoors or fitness. So these are the 6 tables that we have. Once you get the notebook, sorry, you can just load these. Remember on this part, because I saw last week, a lot of you were asking Coyote to go over this part again. When you get this notebook, the part I've highlighted here, please put your SQL database password. So whatever password you had, you remove this part that says your password and input your own password. For the reason of security of my own SQL, I had already run this part before the webinar, so that just in case someone decides to try to be funny and try to use my password, they won't be able to do it. All right. So with that being said, we will now go into understanding our tables, right? So you never know, guys. I can see you laughing. You never know what anyone thinks, right? So when you go into your database, you need to understand the type of tables that you are using and why you are using them and what's in them. So for this, we're going to quickly run and we're going to see what's within our tables, right? And so here we can see like, okay, so our customer ID, it's got the first name, last name, email, password. Again, this is data that was actually real data. And because it's real data, we had to obviously, remove people's emails and passwords for data privacy policies and all that stuff. So email, customer, street, city, state, zip code. Okay, so this is what is it within our customer entity. And then when we run this, we can see, okay, our orders table has got order ID, the date, the foreign key, customer ID, and the order status. Sorry, excuse me. And then the next one is order items. In order items, we can see, okay, we've got the order item ID, primary key, order ID, foreign key, product ID, foreign key, multiple foreign keys, and then, the quantity, subtotal, and the price, right? And so we're going to just do the same run for all the tables. And I encourage you to do this every single time you get data, because you never know what is within your data, for example, and how the columns are named when you're carrying out your queries. So lesson of the day, always open and check your data to see what's going on, right? And so we can see, okay, in our departments, we've got the department ID and department name, categories, department ID and category name. And then for our final one, the products, we've got the name of the product, the description, the price. And if we scroll down here to the end, we can see, okay, the product image as well. All right, so now that we've familiarized ourselves with the data, we can now actually go into section 2, which is what is a join. So a join is a statement that is used to join data from 2 or more tables in a database based on a common factor or element between them. So why do we use joins, you might ask? Well, joins help us integrate multiple tables so that they're easy to read. So remember how our database, we've got 6 tables that are going on. Now imagine trying to build a query that has to link 3 or 4 of those tables, even 2 of them. It's going to be long, complicated. And so to make it so much easier for us to read, we use joins. They also help us to provide an efficient and accessible way to access and combine all the information in our database. So using join can also reduce data usage and storage on the database. So, this is part of optimizing your data. Instead of having too many queries that drag, that require a lot of computational power, we use joins, right? And so I'm just going to take you through this little quick exercise. And this website, you can always go through it yourself once you get the notebook to help you understand SQL joins better. So on the screen right now, we've got a Venn diagram that's got A set and B set, right? Now we're going back to school mathematics, high school mathematics. I I can't remember first primary school. It's been that long for me, guys. But anyway, right? The Venn diagrams, we can see intersections and everything. And so when it comes to joins, think of it as joining these two entities together, right? And so what happens here is with this one, you can interact with it. When you select the intersection here, it will tell you like, oh, this is the inner join that produces only a set of records that match in both table A and table B. And it will even give you what type of syntax you can use for that type of join. So we can even say, oh, this is a left join that produces a set of records only in table A, but not in table B. And then it tells you the syntax that you are required to use. So you can play around with this when you've got the notebook and see the different types of joins. So let's now get back to our notebook. So as we introduced in that diagram, we'll only be focusing on 4 types of joins in this webinar. Why? Because there are other, usually they're like, there are a number of joins, but we don't want anyone to be confused. We want everyone to go away from the webinar with understanding. So the main joins that you'll actually be using for your integrated project are your inner join, left join, right join, and full outer join. So your inner join, what is essentially does is it only brings out the results of matching records in both tables. But do not worry, we're going to go into even more depth with all these different types of joins. Your left join returns all the records from the left table as we witnessed here in our join, where it's only the A that brings out the results and any matching combination from the right table. The right join is exactly like the left join. The only difference is that it now references the right table instead of the left. And then the full outer join combines both the left and the right join together. But we will go into more depth again, as I said, for both of them. And I think I do need to warn you on this one. The full outer join is not supported in MySQL directly and in some other SQL tools. So I'll show you how we actually make up, or how brilliant people thought how to bring out the full outer join. All right. So with that said, as you saw, I was saying outer join and inner join. So there's outer and inner. So an outer join returns matched and unmatched values from either or both tables. An inner join, which is the default in most SQL tools, returns only the records that satisfy a defined condition in both or all the tables that are there. All right. And so here's a diagram once again of all the different joins. As I said, I can't exhaust all of them because of our time. But these are all the possible permutations, combinations of joins that you can have with the syntax. So you can go through it, learn it. If you want to learn more about it, there are resources on Athena, once again, to help you through these ones. And you can always research on your own as well. All right, so now that we've established, okay, our 4 different types of joins, now let's go into even greater depth into the different joins that we introduced. So we'll start with the inner join, which is our simplest join, also the default join that is used in most databases. All right. Our inner join selects records from common matching values between them. So what this means is that, for example, think of our customer table and our orders table, right? If the customer ID is in both tables, both the customer and order ID, those are the records that we are only able to see. However, if that customer is not in orders table, then we would not be able to see them at all. So what it does, it selects all the rows from both tables as long as the condition of the customer is in the orders. So remember, customer can be in the customer table, but they haven't made any order. So in that case, the condition is not met, because for them to be in the orders table, they need to have at least made one order, right? So that's what we mean by inner join. And so here's the syntax to make it easier for you when you're now building your own syntax for that inner join, right? So you always start with your select clause, and then you select your column name or names. You choose the table that you want to start with, and then you use the clause inner join with your second table, where the table, where the primary key matches the foreign key, right? And so this is why, as you can see, now all the concepts are now building up, right? They're all building up from where we started. Now everything is beginning to make more sense, right? And so with our query here, let me just start by saying, our question is, we need to show all orders with customer names, right? And so for this one, I'm going to show you how we would have done it if we did not use a join statement. And then I'm going to show you how to do it with a join statement and let you see just how simple and straightforward it is, right? And so here we want to say show all the customer names. So what I'm going to do is I'm just going to say select, let's say all, okay, yeah, I had not completed that one. Do not mind that. So I just say select all from orders, and then where, all right. So here, let me say I'm looking for just one, yeah. So we can actually run this as is, and we can see, okay, there are 68,883 rows. And so here we can see, okay, what's happening? All right. Okay, am I still here? Great. Okay, great. So we can see, okay, we've got 68,883 rows. That's a lot of information to go through, right? And so now imagine if we were to try and get that same order. So instead of using this large number, what I'm going to do is let's modify this question to where, let's say, where the order, okay. Okay, it seems like my, okay, yeah, where the order is equal to order ID order ID 1. Since we do not want to use all 68,000 records. So now that we've established that, I'm going to just collapse that. And we're going to use the where clause and say where our order ID is equal to 1. And now when we run that, instead we can see, okay, now there's one row or one record that we have, which is, okay, this was the order one that was made, and the customer ID is 11599. So we're going to just quickly put that on the side here as a comment, and we're going to say 11599 so that we do not forget this. So now remember, we wanted the customer name, right? Who had this order ID of 1. So now since we've got their customer ID, we can now go back into the customer table and then look for them. So we say select, we can say select all from customers where where our customer ID is equal to 11. What was that number again? 11,599. And we close that. And when we run that, we can see, oh, so this is the name of that customer, right? Their name is Mary Malone, and they made that order. So now that we can see, we used two different queries to try to get this result, right? And so now let's actually do this in a much simpler way and a much faster way. So how can we achieve this? So I'm going to just quickly delete that. We go back to this and we start from scratch, right? And so we can now say select. So in this case, now we want to show all the names that were there previously. So we start with our select clause. And remember, we wanted the name. So we can say the order ID. I'm going to give it an alias, and I'll explain why I'm giving it an alias in just a moment. Order ID and the order, let's say the order date, or sorry, dot order date. And then we want also the customer name. So C, customer name. Customer name. Yeah, we had first name and customer last name. And then we want to then say all of this from our orders table. And then this is the reason why I'm putting aliases. Why we've got the O, this is an alias to tell, SQL, like you're referencing the orders table. And C, to tell it you're getting this information from the customers table. So when you're doing joins, you always need to alias your tables. This is best practice, and it makes it easier for you to actually follow what it is that you're doing, right? All right, so we're going to say in a join our customers, C, alias it. So always remember when you're now naming your table, you put your alias of O, you put your alias of C, or whatever alias you do choose. All right, great. So before I go on this one, if we remove this part, do you think in the charts that if I run this query, that it will run? Do you think it will give me an error or it will run as is? It's a simple yes or no in the charts. Yes, it will run. No, it will not run. Okay, I see thumbs up. Does that mean you agree that it will run? If we ran this one as is, do you think yes, no, error? Yes, it will, error. Yes, error, 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 error. Okay. All right. Yeah. So in this case, some people are actually correct. Yes, it would run. It wouldn't give an error. Why wouldn't it give an error? Because this is another type of join. It's joining on customers over here. So this is actually another type of join called a cross join, but it's actually very rarely used in SQL. The reason being a cross join, I do not want to run it because I've got too many records. If my records had only 10 or 20, I would actually run it for you guys to see. I'll close the chats once again. But because I've got too many records, I will not run this. Otherwise, we'll be sitting here for a while and you'll be staring at the screen, wondering what's going on, and I'll be too awkward trying to explain through this. So why we really use the cross join is because it does, it's a join that does combinations, all possible combinations. So it's not just like one possible combinations. It's like all possible combinations of all the records within our table, right? Sorry, let me just, yeah, there we go. So it's like all the possible combinations that can happen between order table and customer table is what would come out. So now imagine I've got 68,000 records within my table, within just one table, and however much is in, the orders table. Now imagine if it's doing all those combinations of the different table. It probably would be like, I don't know, several hundreds, millions of records that are brought back, which is why it's a cross drain. But we are not going to use the cross drain. Instead, we are going to join it on, to make our life easier, we're going to join it on our foreign key and primary key, which are, remember, our customer ID in this case. So customer ID in our order table, where it's equal to customer ID in the customer table. And now when we run this, okay, I'm just going to quickly set a limit to it so that it doesn't bring out too many records. Okay. Seems like I've got an error. Where is my error? This stuff does happen, guys. So let me just quickly try to... Okay, let's quickly just change that to inner join. Enter. And when you run that, it's still giving an, okay, an error. It's fine. Let me try and remove that. If we run it, we're still getting an error. All right, these things do happen, guys. Let me just quickly see what my issue might be. Okay, so we said select order ID and order date. From orders, inner join customers, C on. If we run it, it's still giving problems. All right. Limit 10. Okay, let's start with, if we say all of them, let's see if it'll run. Interesting. Okay, so select all from our order. Or is it because, is it order or orders table? Sorry, guys, let me just quickly go back. Orders. Okay, so I think that might have been the error right there. So it was orders. If we run that, there we go. So you see, guys, it's very simple things that can lead to the error that you're going through. So in this case, I'd simply forgotten the S, and that was the error, right? And so when that happens, do not panic. Just go through everything calmly. So you see how it's very useful to open your tables before, because now I would have been like, okay, what's going on? At least the tables are open. So I was able to just quickly go and say, oh, that's my problem, right? And so do not worry when you run into these errors. We all run into them, all right? And so now we can see like, oh, this is all the information of our inner join. You can see that it's given us now the two tables. We've got the order table, which is here until our order status. And now we also have the customer table joined together. And so this is what an inner join does. It brought all the information of the customer names that had orders, right? And so if there was any customer who did not make an order, they would not appear in this list, right? So now that I've explained the inner join, let's say maybe, you don't want all the information and you just want the name of the customer and nothing else. That's when we then rebuild in that. We say that order, we can say order ID and O alias. Remember to always alias, order date. Maybe we can even throw in the order status. And then from last week's webinar, I'm going to ask you this, guys. From last week's webinar, or from your knowledge of SQL functions, which function can I use to join the name and the surname in the chats? From your knowledge of your functions and keywords, which, oh, perfect, concat. Yes, concat. There we go. I can see we already have some data analysis in the house. We've got a lot of data. So you guys, you can do these things, eh? You already know exactly what's going on. So I'm just going to join the customer name, first name, and customer last name. I'm going to put a space here so that it leaves a space between the first name and last name, and then we say customer last name. All right, and I'm going to close the chat once again, and we do that. Oh, where's this mouse going? And we do last name, and then we close all that. And now give it an alias of customer name because I do not want my, yeah. So when we now run that, we can see, oh, so now we just have the order ID, order date, order status, and their customer name, right? Instead of having all that information. So as you can see, the join makes everything so much easier to put all your information together. All right. Now that we've gone through the inner join, remember this is your default join. So I just want to show you another cool thing, why we call the inner join the default join. When I run this query, you can see it gives the exact same result. So in MySQL, when you maybe forget to put like inner join, MySQL will recognize it as, oh, this is, you're trying to say inner join, right? And so there's free knowledge, right? So now that we know what the inner join is, let's now go into the left join. So our left join is sometimes referred to as a left outer join. Now we're differentiating the inner and the outer, all right? What our left join does, it returns all the records from the left side of the join, which is our table 1, and the matching results records the right from the right side, our table 2. It gives null values. So what this means is all the records from, for example, from orders, they come with the result, but it only brings matching results from, let's say, for example, the customers, right? And if there are no matches, it will just write null from that right table. Now, the outer join part is used to differentiate it from the inner join, which only, remember, our inner join only returns matching values in both tables. So the difference between the inner and outer is that this one only matching values. This one, if there are no matches, it will still bring those values, but then it will put null or none in those particular values. And our syntax is the same. It's like we use the left join here, still use your foreign key, primary key to reference it. So in our question, we want to find products that have never been ordered. So to do that, we come here, we simply delete that, and we start with the select clause. So for this one, because of time, I would have loved to build it alongside with you guys, but because of time, I'm just going to quickly write it out. So we're going to choose products. So we want the product name from our products table. And we're going to alias it as P as usual. And then we're going to say left join. So now SQL knows, okay, we're going into the realm of left joins, right? And we're going to say left join, and we're going to go into order items since we're looking for products that have never been ordered, right? This is a keyword here. So we're going to say left join on order items on our keyword here, P for product ID. This is within our product table, and then OI for our product ID again, the foreign key in product ID. And then we're going to say where, because the keyword here is never. So what we're now looking for, remember we said if there are no matches, it gives null. So in our case, since it has never been ordered, it means there'll be no match made there. So we're going to say where the order item, oh, sorry. Sorry, I'm not a fast typer today. It's very cold. If you're in Johannesburg, if you're in South Africa, genuinely, you know what I mean. So my hands are a bit frozen. So now if we run this, okay. Product ID. Oh, sorry, my bad. If we run it again, there we go. Yes, guys, it's harsh out there. And unfortunately, I don't have a heater, so you deal with what you have. So now, as you can see, we're looking for products that have never been ordered, right? And so why we use the is now is because we're looking for, remember, one of the conditions of the join, if there are no matches, it'll give us a now. That's why we're using the is now keyword here. And we can see, oh, so these are all the products that have never been ordered, right, from the catalog. And now that that's done, you can always practice on your own. So the key thing or the key logic is to just understand the rules that govern, all the different joins. And then you'll know like, oh, okay, this is how I can then tackle the question. All right. So now for the other two joins, I'm going to show them in my SQL workbench, because it is important to understand how to use MySQL Workbench and to see how the output comes out. But what I will do is I'll quickly explain them here, and then we'll do the demo in MySQL Workbench. So now for our right join, it's very similar to the left join. The only difference is that the table, it references the right table rather than the left. And anything that is not matched, it still gives your null values. So remember, in our case here in the left table, we were referencing the products, which is why we got the product name, but the order item was our right table. If we were to reverse that, in the right join, it would just simply be the opposite, right? Of the table on the right, or table 2 is the one that we're now getting the information from. All right. And now, once again, guys, you will have access to this notebook, so you can go through these and try them out as well. And now the full join, why I left the full join for last is because it's simply a combination of your left join and your right join. You are simply putting all the results from left join and right join together. That's what your full join is. right? And it's an outer join. Once again, not an inner join, but a full outer join. So yes, the set is just left join, right join, including all your unmatched rows, and all that you see will be null when there are no matches. Right, now let's quickly switch over to my workbench, and maybe we'll do 2 more questions because I do not want to, I do not want to keep you guys for too long. All right. And so at this point, let us go grab our questions. Once again, for our right join, we'll just say find customers who have never placed an order. Go back here. We'll comment this out. Right. And so in this case, we want to find customers who have never placed any orders. So what we're going to do is we're going to select, and we're going to, so I'm going to start it very simple. We're going to select all, and we're going to say from orders, from orders, or giving everything an alias, and we're going to say right join, customers C on, or keyword O, which is the order ID. Let's see. No, sorry. This is actually supposed to be customer ID, because those are the common keys, is equal to our customer ID. All right, and then in this case, we're looking for those who have never placed orders, but I'll just quickly run this one for you to see the results. And let's do this. Okay. Customer ID. Oh, today I have so many typos. I'm sorry, guys. I'm sorry, guys. I don't know why I've got so many typos today. But there we go. Let me just quickly enlarge that so you can see. Right. So as we can see here, when we selected all from the orders table, right, join on customers, you can see that, okay, so this is the information of the customer that is coming through and the orders that is coming through. But now we want those that have never placed orders, right? Because this is joining both tables. So instead, we're going to use our where clause, where our order ID is now. Yeah, is now. And now when we run that again, okay, you can see all these now values. So now you can see like, oh, so these are the orders. What I was saying, these are all customers that have actually never placed an order within the database, right? And so this is what the right join does, and the left join as well. Now you can see it full action. Any result that does not match, it just gives now, 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 now. So now, if we don't want all this information, and this is very important, when you want to save your computational power, especially when you have more complex queries, it is important to not use the select all or asterisk when you're in your select clause. Instead, always be more specific, like, okay, I want the customer name. For example, customer name, I'll say customer first name, customer last name. I'm just going to copy paste this so that I'm quicker. Copy, paste, change this to last name, and then write the customer ID. See customer ID. And then when we run that, we simply get, oh, sorry, when we run that, once again, we simply get customer names and their customer ID. So as you can see, this is all very crucial information that you use when you're building up your query. So again, as I said, it's all about laying out your logic and how everything works together, fully. So now you know, like, oh, okay. So if I want to find things like, oh, they've never placed orders, I can use a left join or a right join to find all the null values within my data so that I can get the result that I want, right? So we are building that logic, right? That's what you want when you're building your queries. And I think the last one I will show you is the full outer join so that you know the syntax that we use for the full outer join. So I'll just do that. We'll go back, get the question from our notebook once again, and we will edit, copy to our SQL workbench, and we'll read the question, right? So our question here tells us to find all the products in their category, including those uncategorized products and any empty categories that might be there, right? And so always identify your keywords of what your question is asking of you. So here it's all, we want all products and all categories. Because of that, we'll start with the select clause. Once again, we will do all, okay, I'll do all for now, but remember what I said, when you're running, when you've got more complex queries, guys, always put column names rather than all. But for us to see what's going on first, I'll put all and then we'll say products, products, alias P. Oh, where did that come from? Enter from left join categories, because we want products and categories. So it already tells us you're getting the table from entity product and from entity category. So category C on P dot product. Okay, sorry. Category ID. Let's see. And then equal to C dot category ID. And when we run, okay. So now here's the part where the full outer join, and this is someone brilliant who came up with this. They're like, since SQL can't run full join, so I'll just show you why it can't. When I say full join and I run this query, you'll see what I mean. I get an error, right? And so this error is like, we do not know what full join is. So instead, we'll change it to left join. Now, how you create a full join is you use the keyword union. Union, from the union, you then remember how we said the full join is a combination of left join and right join. So now we're going to also combine all the information from our left join. So we're going to say select everything from, once again, the products, alias it as P, and then we're going to use the right join. And then we're going to get categories. And we're going to say just the same as above. We're going to say P dot products, yeah, P dot category ID is equal to C dot category ID. And when we close that, and now when we run it, let's come here. Okay, what is the unknown column P? All right. Category ID. Oh, is it known as prod? Did I not change this one to product? Let's quickly just product when we run it again. Okay, it's referencing the one on top, not this one. All right, so let's just quickly troubleshoot what might be going on. So we said select everything from our products table. Oh, we did not alias it. You see what happens when you don't alias. Okay, now when we try and run this query, okay, we're still getting an error. Let me just decrease that. Okay, so from products table, left join our categories, it's got its alias. Okay, let's remove this part once again. Let's remove this part once again. If we run it once more, there we go. It's been fixed. So what our full join essentially did is it pulled everything, left join, right join, whether they are nulls or no nulls. And I'm just going to go to the very bottom so you can see what I mean. So you see product table category ends here, and then the product is this side, right? And so there are nulls in both because we joined left join and right join together. So that's how you create your full outer join. Unfortunately, because of time, I won't be able, I wanted to do a super complex one with you, but it's fine. What I'll just do is I'll add to the information that's there, the context, and I'll explain and break down the query and why you're using such a complex query, and you'll be able to now also do your integrated project. So all these resources, they are in the slides. The additional complex queries, I'll just put them as an extra resource that you can always go through. And now let's go back to the webinar, to the slides. Now, with that said, we've gone through, all the complex queries, the joins, the ERDs. We've seen how the primary keys and foreign keys help us to, better understand the relationships between the different entities and how the tables all work together in a bigger database. But I want you to note that the first 8 sessions, just in case maybe this was a bit too much for you, there are first 8 sessions recordings to help you facilitate your learning and fill in any gaps that might be there. And these are the resources that you can get from them. It also goes through a demo. And just a reminder, guys, you have 3 supplementary tests after your first failed attempt. So please do use your retries wisely. Remember, your first attempt, you can get up to 100%, but your supplementary test, it's kept at 50, and you only get 3 of those. After 3, it means you have failed if you fail within those 3. So please do be careful. And then I will take the Q&A. Questions. Okay, so Carl, when I move a table to the other side in the visualization, it's still visible on the other side. Okay. Let me close this. What am I doing wrong? Okay, Carl, can you actually put this on answer base? Because I don't think I'm quite fully understanding what you mean on the other side. And if it's still visible, please just screenshot, put it on answer base, and then we'll be able to answer you. All right, let me look for, how did I create that table? Oh, okay, Baba Lola, can you please refer which table, and then I'll take your question last, please. please just quickly type in the Q&A which table you're referring to, then I'll quickly go back to it. All right. Okay. Okay, please, how were you able to arrive at infinite? Perfect. Let me go to my SQL workbench, and let's go to the, okay, let's quickly reverse engineer. Should not have closed that. Continue, continue, Wanwa, continue, execute, continue, close. All right, so how we were able to get to infinite was, remember, we're using the min-max rule to establish whether it's a one-to-many relationship, a many-to-many relationship, one-to-one relationship. So when we say infinite, think of the customers here, right? Like a customer, how many orders can a customer make? They can make so many orders. So let's use a practical example. Amazon, right? Amazon has so many orders that are going on there. I mean, I'm sure their users, especially shopaholics, who might even be shopping on there for maybe, let's say, what, once a day, twice a day, making orders on there. And so when you make that many orders and when you put all the orders together, there are so many orders that it becomes so many orders. That's why we use the word infinite amount of orders, because you can't cap on, oh, this person can only order 100 times on Amazon, right? They can order however many times they want from Amazon. So I hope that answers your question. And then let's go back to the question. Okay, where am I? Let me drop that. Drop that. Okay. Where's the webinar? Why can't I see the webinar? Okay. Sorry, let me just stop share so I can find my webinar. And then reshare the screen. Sorry, guys. Okay, so let's go back to Q&A, and then while I'm sharing my screen once again. Okay, share. All right, let's put that on slideshow. And as I go through more questions. All right, and then why is there no relationship between order items and product tables? So in the data set that we did have, why there was no relationship was because there was no foreign key in the products table, or vice versa. The data that we got, because it was data from somewhere else that we got, that actually had real people information and all the transactions they'd done in the company, that data did not have a foreign key, like order item ID in the product table. That's why there was no connection. So remember, whenever you're establishing a connection or a relationship between your different entities, there always has to be a foreign key and a primary key that match in either or both tables. All right, and then the next one, how do the lower tables link to the upper tables? Okay, yeah. So there was no direct connection. Let me rephrase. There was no direct connection between those tables. Simple reason being, there were no foreign key, primary keys that directly linked them. However, with the joins, as I showed you, you can do a left join, right join, or even a full join if we wanted to connect all the different tables together to find how they interact with each other. So that's how you then connect. So it's not directly linked, but you can still link them together. I hope that answers your question. And then how to change the relationship, e.g. when you made mistake, how can you update it? All right, so let me just quickly do this. Let's just share my entire screen again. We come back to this. So if you ever make a mistake of, let's say you put the wrong relationship here, let's say I'm establishing a one-to-one, and I say no, customer ID to thingy, okay. Let's try that again. Customer ID to customer, and I establish a one-to-one. What you can simply do is there's this little back button here. You can use that or use this eraser button over here. As you can see, that you can use to remove that relationship. All right, and then how do you know which column falls under which join? Okay, this is actually a very, very great question. So let us go back to our question over here. So this question here, and this is a very important question actually. You need to read the question and what the question is asking of you. So here we can see that it says find customers. So already that tells you, oh, I need to use customer table. And then the second one tells you who have never placed orders. So that is now telling you, oh, so I need to use both the customer table and the orders table. So it's always very important to read the instructions or what they're asking of you. And let's say maybe you have created the question for yourself. You've got raw data, real life data. You don't have these questions to guide you. It's always building upon your logic of, okay, if I want to find, for example, you've got this data of, I've got, I'm working for a company, I'm working for Mwanwa. She's trying to establish, how many customers, let's say, are loyal to her, right? So that in your mind already, okay, I need to work on customer data or the customer table, and then loyalty. Maybe if you've got like a vouchers table or a loyalty table, you reference the loyalty table. So that's how you come up with those ones, and know which table to reference. And then I have this error. Okay, this might usually be because of the password. Please refer this to answer base, because it could be any number of things that might be giving the error. Because sometimes it's because the database is not there, or your database is not connected, or maybe your password is incorrect. So please refer to answer base. Yeah, this question, please. And then Benedict, can I substitute the on and using column name to do my joining in MySQL? So for this one, I will not lie to you, Benedict. I am not too sure. Please do refer to Anspace. What I'll do is I will research on this for you, and I will get back to you on that one. I do not want to give false information. All right. What about subqueries? So subqueries, yes, I will. Why I did not touch on them today is because we will have another session next week that is purely focused on subqueries and CTEs. And so we will go into how to break down and build up subqueries. All right. Can I use MySQL for my exam? Because I don't know how to use Jupyter Notebook. Oh, Samad, unfortunately, you will have to use your Jupyter Notebook because of the submission format. However, there are resources on Athena that take you through how to set up and use, and even create your own notebook on Jupyter Notebook. So unfortunately, we can't. I missed how you arrived at the ERD. Okay, so for the ER diagram, Precious, I would say please do, just when the recording comes out, you can go through it once again to see how I set that up. Great. So why did we combine join with union instead of using union only in the last exam? Okay, so remember how I said for your full outer join, it actually is a combination of the left join and the right join. That is why we used, because we're trying to do full outer join instead of union. So the best I can describe this is union. If you just use union without any of the joins, it makes your data longer. And then if you use combination of join and union, it makes your information on your table wider. So let's say if we had 10 records, we used union, there would be like 20 records. Unlike when we use the join combined with the union, it'll just be instead like 20 columns rather than 20 edit rows to the bottom. I hope that explains. Does the cross join need much computing power in real time? It depends on the size of your data, Brian. The bigger your size, your data, the more computing power it requires. So use that one very wisely. That's why we really use it. Okay, can you please explain the relationship of joins many to one or one to many? Okay, please do go watch the webinar recording once again. But what I did say is use the logic of minimum, maximum, right? So let's say we are a customer in Moanwa's shop and she's selling Crocs because I love Crocs. She's selling Crocs, the shoes. So I'm a customer, my information is in her database and I'm ordering Crocs, right? So there's only one, the minimum, there can only be one me within the customer table, but then I can order from Moanwa's shop. I can order Crocs, I can order a phone, I can order a laptop, and these are all in different timelines. And so, which means I've made 3 orders. So that's like a one to many already. So always ask yourself, like, what's the minimum amount of a specific thing that has to be in one table, and what's the maximum amount that can be in the other table? And that will help you. But if you still don't understand, it's fine. You'll still meet this concept again in Power BI. Hope that helps. And then are we always supposed to query show tables before to query show tables? No, Dennis, you don't always have to show the tables in Jupyter Notebook. The reason why I did that is I actually do it as best practice for myself. Anytime I get new data, I want to understand what that data is. And so I always just show all the tables to understand how my data looks like. Naming conventions, especially when you're building queries, for example, you saw the small mistakes I was making, like leaving out an S, or, you might name a column and you need to see, okay, how do I misspell it? Stuff like that. So for me, I do it for myself, always open the tables before I actually start building my queries. But you don't have to, no. Okay. I think that is okay. Please, how do we know when to use the right join or the left join? Okay, so for the right join and left join, usually what I'll just say is the most used one by the industry is the left join. And I would also recommend that you mostly use the left join. It's much easier to read, much easier even when you're creating everything, because we are, as human beings, we're used to reading from left to right rather than from right to left. I know there are people that do read from right to left, but yeah, the industry mostly uses left join. But if you want to use right join, that's up to you. Okay, so why does my Jupyter say table not found? Even if the database connected successfully, this means when I'm using SQLite failed, even when I tried running queries from the answer section. Ibrahim, please put this on AnswerBase and also maybe provide a screenshot and we will get back to you on that. Yeah, because I think this needs more context on that. Okay, and then finally, so does it mean that if you want to combine two tables with similar columns, you simply union instead of the joins? Okay, so Rosemary, if you want to combine two tables simply, you actually just use the join. But when you want all the results, so remember how in our full outer join, the question here was, we wanted all the products in all their categories, including those that had not matched. That was the keyword here, including uncategorized products and empty categories. So when you want the null values or to find where there are no matches, that's when you then use the union. But for the rest, I'd advise to use a join. All right. I think, okay, do we really need to use, I think this will be my last question. Do we really need to use full join? It depends on what you are trying to get out of it. You don't necessarily need to use the full join, but depending on the information that you're trying to get out of your data, then you can decide, okay, maybe you can simply use a left join or a right join or an inner join to get the answers that you want. All right. And I think that is it. Oh, and before I do hand it over to Tendai, please, guys, please do go and read the, what the community team is putting out on eHub because it's absolutely brilliant. Some days I go there and I get, I go away from there with a smile on my face. Like they're really key and important stuff that they're giving on the community. So if you're not on community, you're missing out. And with that, I'll hand it over to Tendai.
Thank you, Munesu, for the vote of confidence. Yeah, and thank you for the amazing session. I'm seeing a lot of appreciation notes. Hopefully you can see them on your end as well. Yeah, guys, let's give Munesu some love. Sure, we got what we came here for. I can see even the poll. The outcome is really, really impressive. But if you still haven't interacted with our poll question, please do so now before you leave. Yeah, Munesu, there's some love for you. Thank you so much, guys. All right. Well, not too many new things to talk about, just some reminders. So yeah, we are now on part 3 of our integrated project that is due on Monday next week. So please, guys, let's pace ourselves and start with the content early because I'm sure you can see it's getting hectic now. So it will be wise to start with the project early in the week so that you get into the weekend having done everything, if not most of what you should be doing. And then the part 3 of the project, the MCQ, is now available. Yeah, you should be able to access it now. So just thoroughly go through the content and submit quality assessments. Remember what Munesu said, it's the first attempt that gives you a chance to score more than 50%. The other 3 can only give you a maximum of 50. So please, let's take note of that. And yeah, guys, community, we are there on the community spaces, always trying to hype you up, sharing updates with you. If you're not on the community, where are you? Munesu has already given us a vote of confidence there. So please, at least just pop in, it's a certain time of your day, just check what's happening on the announcement spaces there, on the squads, there's always something we are doing with you. So please just make sure you at least pop in here and there and find out what we have for you. Then I see a question that's coming up a lot, where to find the announcements. I'm sure that's coming from people who are not on the community or who are not busy. Because if you are active, then you should know where to find our recordings. So they are there on the program hub, together with all the other resources that we feel you should be having access to. So just go to the community, you navigate to the data program hub, you'll find all the recordings, all the slides, and extra resources that we share with you. Yeah, I see a message here by our program manager. She's saying if you are still having problems with your Jupyter Notebook, please share that on Answerbase firstly, but in the meantime, please be using Google Colab to practice. So yeah, while you're waiting for Answerbase, we know a lot of complaints are coming. Just be patient with us as we try to help you guys set up your machines. But in the meantime, please be using Google Colab. Others are also finding other alternatives. So yeah, please just get busy with something, anything, as long as you're not sitting and waiting for answers. Yeah, I think that is all from us for today. Yeah, remember, if you still haven't interacted with the poll, it's still up, closing in a minute. So please, yeah, just give us some love. That is all from us. Thank you.
Kutoka alo nilikutana naye Kilimani, Nairobi 2015, kibaridi cha asubuhi, kijua fani sio kikali saa 5. Nairobi 2015, nikamchagua yeye katikati ya wenzake 5. Nikamuomba kaniomba namba, moyoni Mungu nikampa 1. She's my number 1. Nikamuomba kaniomba namba, moyoni Mungu nikampa 1. Now she's my number 1. Yani namaanisha kwamba ndo tushawana. Tulipatana Bongo, Mikocheni, kwa zangu bichi nalo upepo wa bahari. Alinipita kama meli, anayumba yumba akidondosa kishenzi. Mikocheni, kamfuata utadhani zombie. Habari gani mbona uko lonely? Jina ni gani? Akasema Zari. Nikamwambia aje, kamwambia kwangu ni kwake. Nimshike wapi ndio aje? Taka moyo wangu we wake. Watangoja sana wakidhania tutachana, mina yeye tumeshaivana, na ichapo siku na mchana. Yani namaanisha kwamba ndio tushawana. Na yeye sami tunaye tushawana. Tushawana na yeye sami tunaye tushawana. Oh yeah,